Again, good afternoon to all. So basically, we're finished with the topics that concern the understanding of uh, the BJT as an amplifier. Okay? Wala pa nato na-cover pa, yun, ang BJT as a switch, no? And all the other circuits possible for BJT, for the BJT for the BJT. Focus lang kita mainly sa BJT as an amplifier. Its characteristics, its operations, how to bias it in its DC mode, and how to use it or how to analyze it in its AC mode, considering it, that it will be connected with a load and a source. No? So ato na discuss in length for the previous meetings. So this afternoon, and for some time, for few successive meetings would also, this would be our electronic device in question, field effect transistor. So field effect transistor is another flavor for transistors. Kaya duha lang gid kabuok ang types of transistors. We have the BJT and the FET. Okay. So this slide summarizes the similarities and differences of BJTs. So ilang similarities kay sa ilang applications. Both BJTs and FETs could be used as an amplifier, as a switch, and as an impedance matching circuit. Okay. So ilang differences are more numerous kaysa sa ilang similarities, and well, in fact, ilang similarities is naman guys sa ilang applications. No? So kaning mga similarities is with respect to their applications. Meaning on how they will be used. So ilang differences speaks more of their basic characteristics. Okay. Of their characteristics. Because internally, lahi gid ang pag-manufacture sa FET kaysa sa BJT. No? They are two completely different devices. Of course, they are transistors, meaning one terminal controls the flow of current sa other two. Basically, mo ang definition sa transistor. Okay? Whether FET or BJT, one terminal controls the flow of current sa other two terminals. No? So whether this is a BJT or FET, muna ilahang basic na operation. Okay. So for the BJT, we've established na for current to flow from the collector to the emitter, dapat na current pong flow sa base. Ibahin nga naman tong BJT. FET, the same gyapon current will flow from this terminal to the bottom na terminal. So the terminal on top, we call it as the drain. Okay. Letter D. Sa silong, we call it as the source. So muna yung main nga channel. Dili mo flow ang current from the drain to the source. Kung sa BJT ni, from the collector to the emitter. So dili is drain to source. Okay. So medyo bali lagi, sir. Di ba ang drain kung sa kuan pa faucet, ang drain tong bangag din, ang source ang gripo, no? Because ang electron flow is from source to drain magyad. No? If you consider na to ang electron flow, it's always from source to drain, the flow of electrons. But we're not considering the electron flow but the conventional current flow, which doesn't make that much difference man if ang atong objective is to analyze its application of circuits. So, conventional current man atong gina-follow, current will flow from the drain to the source. But ang difference niya sa BJT is dili ta magbutang og current sa kaning terminal. We call this terminal the gate. Okay, the controlling terminal of the FET. So for the FET, we do not need to apply current to the gate, but we should connect it to a voltage source. So yan na ang main difference between the gate, between the BJT and the FET. Whereas the BJT are current controlled devices, FETs are voltage controlled devices. Okay. Or somehow we could say that FETs are voltage controlled current source. Whereas ang BJT kay current controlled current source. Diba itong model sa BJT kay dependent current source, even especially sa katong nag-AC analysis na ta. Diba, this is the model of our BJT. It's a current source or dependent current source, dependent upon IB and beta. Also, FETs have a higher input impedance, whereas the BJTs have higher gains. FETs having a higher input impedance means the FET as a device, okay, not the FET amplifier. Well, yeah, mag-follow gid gihapon nga even ang FET amplifier has ZI, a very very large value for ZI. ZI is equal to infinity. Diba? We have known ZI to be input impedance. So the input impedance of the FET device and the FET amplifier is a very large value. Whereas BJTs have higher gains, no? Beta, AB day. Higher gain. Of course, we could design a BJT to have a unity gain or gain is equal to 1. Pero BJTs have relatively higher gains compared to FETs. That's why atong established na kalundaan that FETs are really not that good amplifiers compared to BJTs. So, shorthand lang ni siya na when designing amplifiers or even amplifiers that are available right now, most of them are made from BJTs. So, ang other na applications for transistors, which is the switching, is more or mas mag-shine more ang FET sa switching applications. So, although, again both devices could be used as amplifiers and switches. Even BJTs and FETs, both of them could be used as amplifiers and FETs. But BJTs work well as amplifiers and FETs work well as switches. Pero still, magsugod gyapon ta sa pag-understand sa FETs as it is being used as an amplifier. So FETs are less sensitive to temperature variations and are more easily integrated on ICs or integrated circuits. So FETs are less sensitive to temperature, meaning more versatile siya, more rugged. Mas mag-work siya for even a relatively high ambient or environmental temperature compared to the BJT. And actually, di man matter, di man magubang BJT, di ba? Di man magubang BJT kung init ang environment. It's just that mag-vary ang beta, no? Ang internal na current gain, which is beta, varies with the temperature. So, not so with the FET. FETs are insensitive to temperature. Or dili kaya siya maapektuhan sa init nga temperature. But FETs are generally more static sensitive than BJTs. So, even though dili sa temperature sensitive, static sensitive sila, that's why, in a more practical na sense, we do not handle Bjts, no, we do not handle FETs using our bare hands only. Okay? So if we touch FETs and napadaytay static discharge sa atong fingers, most especially, maguba di siyang FET, no? Wala pa nagamit. Guba na siya. Kay wala mo ito nagamit og isa ka device. So itaw ka ng device ay ESD strap man siguro. Anti-static wrist strap. No? You could look for it sa internet, maybe sa Lazada. Anti-ESD strap, wrist strap. So for us to handle FETs, we should have this connected sa atong wrist. Anti-ESD. Electrostatic discharge wrist strap. Picture na sa internet, so pwede na nyo lang kita. Malalagi siya strap. No? Ano yung nakakonect na wire. And this wire should be connected to a sort of ground. No? So, anti-ESD wrist strap. Because FETs are more sensitive to ESD. Okay. So, generally, mo lang mga similarities and differences. Bird's eye view sa ilang similarities and differences. Because, yeah, technically, totally different gyud ang FET and BJT. But what amazes us is even if they are totally different devices, they could both be similarly used as amplifiers and switches. While in fact, pwede ganit na mag-cascade o FET ug BJT amplifiers and mag-work sila together. No? Again, even if they are two different devices. So these are the types of FETs. We have the Jfet and the MOSFET. Actually, na pa isa, MESFET. Not commonly mentioned sa mga sources. MESFETs. MESFET. So, ang Jfet or junction FET, for the most part, mag-focus na dire because, again, even if BJTs are more efficient as amplifiers, pwede magyapon ang FET. Pero if FET ganit siyang amplifier, for sure it's a junction FET. So Jfets are used mainly as amplifiers. Or if we want an amplifier to be made of a field effect transistor, we will use Jfet. Whereas MOSFETs are used for switching. Switching circuits. Whether low power switching, whether low power switching sa discrete na components. Discrete meaning kanang mga component natong connect sa breadboard, or whether integrated circuit na package. Integrated circuit meaning katong mga chips bitaw, ICs. Kana sila. So this could be made up of tens or hundreds or thousands or even millions of MOSFETs inside the IC. Kaya kung discrete nga component, ang isa ka ana, isa na siya ka MOSFET. Whereas kung IC, this might be made of, again, tens or hundreds or thousands or even millions of FETs inside the integrated circuit. So again, Jfets work well as amplifiers and MOSFETs work well as switches. The not commonly mentioned best FETs, yung applications daw more of in the RF nga field. RF or radio frequency circuits. They're using MOSFETs. So we'll start with the Jfet. Siguro from now until mahumanta sa AC analysis of FETs, we'll be dealing exclusively with Jfets. Inunduma tong atong mga naagiahan bitaw sa BJT. No, you try to remember all of it. Tanan nato nga naagian nga processes gikan sa DC, then to AC, then to two-port systems and cascaded networks, katotanan, then using tables, deriving formulas. Muwag na po ato, no? Muwag na po ato. But this time, FET na po atong gamiton. So magsugod na po probably next meeting or even later, ma-introduce siguro na ako sa DC analysis sa Jfet, deriving the currents, yan na. And then, gyapon tanan circuit, fixed bias lang siguro, voltage divider, kaya ang mga formula naka-summarize gyapon sa table, no? Again, we'll still be using tables, no? Very convenient gyapon. And ato gyapong i-end ang atong discussion sa Jfet with the topic that we discussed last meeting sa BJT. Two-port system and cascaded amplifiers, RL, RS, kato. So, katotanan, but this time, Jfet. So, this is the physical construction of a Jfet, junction FET. So, for each type of FET, lahi sila ang physical construction. Ang next sa BJT, isa lang magiging ka type of BJT. BJT naman, duha lang kaklase ay N-type of NPN and PNP. So, the same naman gyapon ang ilang internal construction. Compared sa Jfet, no? Lahi ang Jfet sa MOSFET, lahi sila kaysa sa CMOS. No? There's also such thing that we call CMOS. There are numerous kinds of MOSFETs actually na depletion type, enhancement type, and apoy lang own different physical construction. So again, basically the klase nga FETs. But this one, sa slide, this is the Jfet junction FET. There are two types of Jfets in the same way that there are two types of MOSFETs na N-channel and P-channel. So here, unlike sa BJT na yan naman to, di ba? NPN or PNP, nag-layer siya. Kani, it has only one layer. Its main channel and channel. Kaning P-type material here, dili na siya as big as drawn sa kaning figure. Okay? Dili na siya drawn to scale. Technically, gamay na gid ni siya. Ayan na. So, dili siya matawag nga 3-layer device in the same way nga that the BJT is a 3-layer device. It's either N-channel or P-channel lang. So, N-channel is more widely used because ang majority carrier sa N-channel, because N-channel is an N-type material, are electrons. So, mas paspas ang electron flow kaysa hole flow. So, its three terminals are drain, source, and gate. Drain here, source here, and gate here, the controlling terminal. So, yung basic idea, analogy for how Jfets work. Para magyapon sa di ba? Sa BJT. For current to flow from the drain to the source, we apply pressure to the gate. Voltage type of signal. So we understand this if we just go to the characteristic curve. Ito na das characteristic curve mo kuan. Mo focus sa yung operation. So what happens is, if we apply voltage sa P na terminals, or sa gate, I mean, kay sa P terminals man nakakonect ang gate, the depletion region will widen. Widen siya. Just like here. Originally, di ba, ano man to? This is an unbiased na FET. So if we apply voltage sa gate, so the depletion region widens. So if VGS is equal to 0 and VDS is further increased to a more positive voltage, then the depletion zone gets so large that it pinches off the N channel. Pinch off such that ma-constant na ang amount of current na mag-flow through the device. This suggests that the current in the N channel would drop to 0 amperes, but it does just the opposite. As VDS increases, so does ID. The effect on pinch off, no? Remember, if we apply voltage to the gate terminal, the depletion region, this one in gray, increases to a point that somehow mag-touch sila. No? That's why pinch off ang tawag kay na pinch nga gaka happen. No? If we try to pinch our two fingers together, thumb ug ang forefinger. So, allowing current to flow in a more constant kuan. No? So, dili man noon nga 0 amperes ang flow sa current, but it will flow to a more constant na level. No? So, mas better ni makita sa kani, no? sa characteristic curve. At pinch off, any further increase in VGS does not produce any increase in ID. So, ID is at saturation or maximum. So, let's try to focus our attention sa characteristic curve. No? Totally, again, based sa atong makita right now, dili ani ang characteristic curve sa BJT, right? So, again, because they are two totally different devices. So, the x-axis is VDS, the voltage across the drain and the source. Kung sa BJT pa ni, mo nitong VCE. No? Mo nitong ang counterpart ani sa BJT kay VCE. ID is yung counterpart IC. IC and IE. Yeah, IC and IE. So, mo nang y-axis. So, notice, when VDS is initially at 0 and increases in value up to a point that we call VP, increasing ang current. Okay, so mo-increase siya. As long as wala pa na-reach ang VP, mo-increase lang ang value sa ID. But once VP is reached, and this value is could be found sa specification sheet. So, naroon na sa specs, kaning VP, naroon na siya sa specs. Makita lang na dito. Or kung mag-analyze mga itag circuit, given na siya. So, once VP is reached, the current will no longer increase. No? Hindi mo nun siya mag-stop og flow, but di na siya mag-increase. It will stop increasing at this value that we call IDSS. So again, when the voltage across VDS is increased, current flowing sa ID will also increase. Up to a point when VP is reached at the value that is IDSS. So this is the saturation current, IDSS. And this is also given, or this is also constant. Nagyabot na siya sa specs. Makita na siya. So, ano lang, no? That's how Jfets work. Kayo. Easy for us to understand. So, P-channel Jfets work the same way. Balihon lang gyapon ang source. Palagi po sa BJT, di ba? Kung magamit tag PNP na BJT, baliyon lang ang source. So, skip lang ako ng mga slides. So this is the schematic symbol for a Jfet. No? Dahil na siya i-draw, pwede na tamag, ingana, and then arrow. So this is the drain, this is the source, this is the gate. Important ng arrow because it determines if it is an N channel or P channel. So ang P channel nga Jfet is, if I'm not mistaken, igana. Pagawa siyang arrow. P channel na siya. So kanina is N channel Jfet. Okay. So before sa BJT, we have memorized, at least no, without referring to the table, we've memorized 4 relationships, which are the primary characteristics of the BJT. No? IE is called IC plus IB. IE equals beta plus 1 IB. IC equals to beta IC. IC equals to beta IB. And VBE is equal to 0.7. Manas lang mga 4 most important and primary characteristics of the BJT. For the Jfet, I think we only need to memorize two characteristics. One is this one. This is called the Shockley Equation, if I'm mistaken. No. Shockley Equation, named after the inventor of the transistor, I think. Or at least this is a version of the Shockley Equation. Shockley Equation. So the transfer characteristic of input to output is not as straightforward in Jfet as it is in BJT. In BJT, beta indicates the relationship between IB and IC, di ba? IC equals beta IB. In Jfet, kani, ID is equal to IDSS, quantity 1 minus Bjs over BP squared. Start memorizing this one na. Because actually, wala ni nga formula good atong i-memorize sa Jfet, wala nilain. For the amplifier circuits, don't worry, mag-refer gyapon to sa table, no? So no need to memorize. Kung di ta gusto mag-memorize sa formulas or mag-refer sa table, pwede na ta mag-derive. Pero taas-taas na siyang trabaho. But if there's one thing na atong yun i-memorize is this one, no? ID or the current across the drain to the source is equal to IDSS 1 minus VGS over VP squared. So some other relationships or formulas, pwede na ito di may memorize, no? Kasi dala naman siya timanan. Remember that one of the characteristics of the Jfet is the device characteristic, not the amplifier characteristic. Zi is equal to infinity, or it has a very high input impedance. Ang isang sa effect ana is kato, no? Budako pod ang input impedance sa amplifier, Jfet amplifier. But because its internal input impedance is very high, we could approximate Ig is equal to 0 amperes automatically, making ID is equal to Is. Okay. Unlike ito sa BJT nga, malag special assumption pa when IE is equal to IC. But here, isa tatandaan that ID is equal to IS. So yeah, I think that lang, no? This is the only formula that we need, at least when we analyze Jfet amplifiers at DC domain. No? So I'll not cover sa MOSFETs for now. Balik na ta sa MOSFET pohon-pohon. Kung mauman na ta sa Jfet as an amplifier, no? From DC to AC. So dili lang sa tataman sa Jfet, no? I mean, knowing the relationship between ID and Bjs. Okay. Kanina sa kanina equation, again, don't worry, because ID, SS, and VP are constants, meaning they're given. So again, Shockley equation defines the relationship between ID and Bjs. Yeah, so I think that's sufficient for us. Those information are sufficient for us to start analyzing Jfet amplifier circuits. So the same gyapon ang names actually sa circuits sa Jfet ug sa BJT. We still have fixed bias configuration. We still have voltage divider bias configuration. Pero tungod dili emitter ang pangalan sa terminal sa FET, counterpart niya sa BJT, ang counterpart sa emitter sa BJT is the source sa FET. So natay ginatawag na self-bias configuration, which is equivalent to emitter bias for the FET. Okay. So for this afternoon, mag-start lang sa tao na sa fixed bias configuration, same as before, no? Sa BJT. So Jfet fixed bias configuration. So this time, di na VCC ang tawag sa itong source. But because this is connected to the drain of our FET, drain mo na siya, we call this as VDD. So muna ang source sa FET, VDD. This is G, or the gate. This is the S, the source. The same way, ng emitter sa fixed bias na BJT is connected sa ground, ang source is directly connected to the ground. In the same gapon, ang gate is na-connect na isa ka resistor that we call RG. Pero dili siya connected sa VDD, no? Unlike lugar sa fixed bias. But it has its own source that we call VGG. VGG. So this is the fixed bias configuration for a Jfet. So let's remember that Ig is equal to 0. Okay. So current Ig here is equal to 0. Okay. So the current move flow padulong sa gate na terminal. So how much then do you think, class, is the voltage across RG?
0, sir?
Yes, 0 gapon, no? So even if na-value ni si RG, but because there is no current flowing across it, wala voltage si VRG. So 0 si VRG. So if mag-KVL equation ta here, KVL ta here, I think bali din akong polarity. Minus plus day dapat ni. So if mag-KVL ta there, so VG, VGG, or negative VGG minus VRG, which is of course equal to 0, minus VGS is equal to 0, right? Therefore, VGS is equal to negative VGG. So kung pilay value dili, mo po yung amount of voltage across VGS. Okay, because 0 man si VRG. So how about here? Sa diha nga side, KVL ta. Sa output na side. So VDD minus voltage across RD. This is RDDI. Minus not VCE but VDS. Then equal to 0. Okay, ground naman after. So if mag-KVL tada sa output na side, VDD minus VRD minus VDS is equal to 0. VDD minus ID, RD minus VDS is equal to 0. So, ang given lang diri is si VDD ug si RD. Unknown si VDS, unknown si ID. But we could obtain ID using Shockley Equation. So, makuha lagi ako si VDS eventually. Okay, so I think wala mo siguro na eh. No? Let's try to solve some example daw. Pwede ko i-arrow dili. Okay, so this is our given. VDD is 16 volts. RD is 2K. RG 1 mega. VGG negative 2 volts or 2 volts connected in this fashion, and given si IDSS and VP 10 milliamperes and negative 8 respectively. Okay. So based on this formula, VGS is equal to negative VGG. So I need to find it. Find ID, IS, and VDS. No need to find IG because IG is 0. Because for the fixed bias, VGS is equal to negative VGG. VGS is equal to negative 2 volts. Kaya mo naning medyo taking apart. Solving for ID. And yung unang kudaan nga tanan, no? Tanan amplifier configurations for the Jfet. Ang next step mo ay pinakataas. Okay? Solving for ID. I think ma-understand na ninyo karon nga nung makaingon ko nga taas, no? Di mo lisod. Taas lang, no? Complex gamay. Compared to before sa BJT. So, ID is equal to IDSS 1 minus VGS over VP squared. No? Again, dapat memorize na siya. ID is unknown. IDSS is given 10 milliamperes. So, ID is equal to 10 milliamperes. 1 minus VGS is negative 2. Diba? 1 minus negative 2 over VP is given negative 8. Squared. Great. Ako lagi dito. Kasi na-save sa kumpuan. 'Okay, makuha din siya. Di siguro sa fixed bias. Sa self-bias, siguro ang lisod na pag-solve, no? Okay, kay kung mang day, no? Di man day, wala man day relationship si ID o VGS. Kaso sa'yo na ni, no? Fixed bias pa man. So, ID is equal to, wala man dito na. Five point six two five milliamperes. Dali naman di ay. So this is ID, which is also equal to IS VGS is, VDS I mean is this one, VDD minus IDRD minus VDS is equal to 0. 16 volts, 5.625 milli times given nga 2 kilo ohms. Answer is 4.75. So, yeah, I think this is the final answer already. So, yun naman di ang fixed bias, no? Mas straightforward pa siya kaysa sa fixed bias ng BJT. Bitaw, any questions so far? So, na ba?
Sir, anong na equal ang ID of ISS, sir?
Kuan, characteristic na gina siya sa Jfet. Diba? Because IG is equal to 0, high input impedance man nga device ang atong Jfet. So, IG is equal to 0 here. Wala current mo flow sa gate. That's why ID is equal to IS. Alright? Sabtan ba?
Yes, sir.
Okay. Masaya naman dahil, no? Ang fixed bias. Nakalimutan ko. Ito lang ito ka-simple. So, let's go to self-bias configuration. So, self-bias is, yung equivalent sa BJT na circuits is ang emitter bias. Meaning one resistor each connected sa each terminals sa itong FET. RD because drain na siya. Source, so RS. Gate, so RG. And unlike the fixed bias, wala na yung source na connected sa gate. Okay, so if mag-derive ta, KVL ta diha. Negative IG RS minus VGS minus IS RS is equal to 0. Right? RG, voltage sa RG, voltage sa VGS, then voltage sa RS. Patungkol kay IG is 0, wala na siya. So we have a relationship for VGS and IS. VGS is equal to negative IS RS. But since IS is equal to ID, this is the relationship between VGS and ID. VGS is equal to negative ID Rs. How about here? KVL to diha. VDD minus ID RD minus VDS minus IS RS equal to 0. Again, since IS is equal to ID, pwede lang makombine si ID ug RS, ID ug IS. ID RD plus RS is equal to VDD minus VDS. Sakto? Therefore, atong din ko lang kay in terms of VDS no data no. VDS mo na itong unknown here. So VDS is equal to VDD minus ID RD plus RS. So this is the formula for VDS. I-combine na ako sila. Kaya para naman si ID ug IS. Diba? Transpose na ako dito. Para positive. So VDS is equal to VDD minus ID RD minus IS RS. Or ID quantity RD plus RS. Example. Diba? So let's solve this example though. So VGS is equal to negative IDRS. VGS equal to negative IDRS. VGS negative IDRS. So VGS is equal to negative ID times or negative, what's RS? 1K. 1K RD. No, ID. Equation 1. Equation 2 is not this one, but gamit tag Shockley equation. ID is equal to IDSS quantity 1 minus VGS over VP squared. ID is equal to what's IDSS? Given 8 milliamperes. 8 milli. 1 minus Vp is negative 6 squared. So, one equation to unknowns. But, let's substitute equation 1 here. So, this becomes ID is equal to 8 milli 1 minus negative 1k times ID over negative 6 squared. So before I proceed, any questions sa akong obtain ng mga equations? Wala pa tanaw man dire ah. So, basin na mo yung question bitaw.
Okay na, sir.
Okay pa? Sige, patayin ko ha. So, ano na? We have ID here and ID also here. Naka-quantity pag yun. So, what do we do? First, cancelas na ito nga sign. So, this becomes ID is equal to 8 milli 1 minus 1k ID over 6 squared. So, square na ito ni R. Ano lang. Usually akong ginabuhat before. So, di libog bitaw. Let ID equal to X. No? Or di rin lang sila sa taas para. Let ID be equal to X. Para kami, X na may dire. So, solve for X. Di 1,000 lang nato ni 1,000. 1K man, di ba? So, 1,000x. So, si 8 milli, muna ito nag 0.008. Mag-algebra. Solve for X. Now, ayaw lang sa among attempt o gamit og shift solve here because quadratic equation na ba ni? Dapat duha ka answer ang mugawas. Pag shift solve, if you notice, isa lang mag-answer mugawas, no? So, ayaw lang mo shift solve at this part kay it's possible nga mugawas nga answer is dili ang answer nga atong gusto, no? Ang mugawas nga answer sa shift solve could be one of the two possible answers, but not both. No? So, ato pa ning i-simplify pagid further. So, this becomes x is equal to 0.008. So naman 1 minus 1,000x over 3 plus 250,000 over 9. Does anybody have a question? Giyon na ako na pag-obtain. Ako lang ning gi-expand. Kani nga portion. Malag something x squared minus something x minus plus 1.
Hello, sir. Sir,
Nag-delay ba dun?
di
Delay
ka
mo dun,
madukan, sir. Yes, sir.
Kani, dungan ako?
Hanggang sa
Yes, sir.
Ah, sige, sige. Diba? So, nanatod di karon, no? I don't know kung asa ko taban ganyan sa pag-out na ko ug pag-off sa mic. But, ako lang gibuhat is gi-expand na ko ning expression nga square para ma-obtain ning nasa silong. And ako lang i-distribute si 0.008. So far, na question sa pag-algebra, ani? Sabtan pa?
Yes, sir. Basically, yung distribute si milli 8.
Si 8 milliamperes. Gi-distribute na ako. And, ako i-transfer this sa taas. Ako lang ning i-combine si 1x sa other side. Okay, pareha naman ni sila nga expression. I mean, pareha sila og degree. So, i-combine ako na para ma-equate to 0 ni siya. So, this becomes 2,000 over 9 x squared. So, negative 8 over 3 minus 1 is negative 11 over 3. Minus 11 over 3x. Then plus 008. Equal to 0. So, we have our quadratic equation. So, pwede na ito mag-calculator here. Pwede shift solve, but katong mode. No? So, let's go to mode. Sa calcu. Mode 5. And then, option 3. So, i-input lang na siya dito sa mode 5, option 3. I-input ang mga coefficient 2,000 over 9 o negative 11 over 3 o 0.008. Basta kaya nga ito makuha. So, you have two possible values for ID. 0.139 plan eh. 1, 2, 3. 13.91 milliamperes. And 2.59. 58. 2.598. Ano? Before ko mo padayon, i-confirm sa ang akong nakuha ang answer if pareha ba ta.
Same, sir.
Same?
Yes, sir.
Sige, so we have two answers. ID is equal to 13.91 and 2.598. So which do you think is, or among the two, is the real answer? So sa itong mga basis. Number 1, we'd look at the given IDSS. Diba? Remember, IDSS is the maximum current sa atong Jfet. Ito dire. Characteristic curve niya. Diba? ID is at saturation maximum. It is referred to as ID SS. So IDSS is the maximum value na for current. If ang atong device has an IDSS of 8 milliamperes, wala na siya iyahang maximum. So dili pwede ning 13.91. So dili na siya acceptable. So the correct answer is ID is 2.598 milliamperes. So natay ID. So we could now solve for VDS. VDS is VDD minus ID, RD plus RS.
Okay, question, sir.
Yes, man.
What if below sila 8 milliamperes ang duwa? Hindi na siya possible. Naging maglaro.
Possible gyapon. Possible na siya. Possibility nga ang silang duha ang musulod, no? So, move na po sa atong ikaduha nga metric. Atong next nga metric is si VP. We'll solve for VP. Mo ba sa si VP dire. Diba, oh? So, let's try to substitute this sa kaning example dili na no need na. Pero what if katong the same sa question ni Arman na silang duha kay both below IDSS. So we'll substitute back ID here and solve for VP. Kung mula pas pagyud gani, so dili na siya acceptable gyapon. Pero so far no sa tanan nako nga na solve nga example sa ani, nagid na isa nga matugma. So katoto mo to ikaduha nga basis na to ang VP. Constant pangyapon to. Di ba VP is maximum na voltage for kuan for wala siyang maximum, basta kayo mo gapon ng di pwede nga mo labaw og VP, no? Ang kuan.
Okay, sir. Thank you, sir.
Hello, mudungan ako balik.
Yes, sir. Mdunggan na.
Sir,
Yes. Asa man?
Tuwi na yun ako nga madunggan na ka, sir.
Okay, sige. Okay. Thank you. So, nanato dili ron. Kita mo sila tanan karon na mag-experience siguro ang low nga kuan signal. So, VDS is equal to VDD minus ID RD plus RS. VDD 20 minus 2.598 say RD of RS 3.3 plus 1 4.3. So VDS is equal to 8.83. Do you have the same answer?
Same approximate answer lang, sir.
So okay lang na siya. So, dire, ang medyo challenge lang yun nga part, hindi kaingon no, pero complex lang compared to the BJT, is ang Shockley Equation, ang paggawas sa ID. Kaya kung masayip tagamay dire, kailangan nyo ba mag-algebra dire o nga part. Sayip lang tagamay, basig mapiktuhan ang atong answer. No? But other than that, pretty straightforward lang po ang flow or process sa pag-obtain sa currents o voltages sa Jfet. Okay? So, the same gyapon sa kuan, BJT, nagyapoy summary table of formulas ang different DC bias configurations for Jfet. Kung gusto nyo kuan, kitaan to, na summary gyapon sa ebook. Convenient gyapon if you have a printed nga copy ana para anytime pwede na ninyo magkuha kung wala mo textbook. Pero if na mo textbook, pwede na nyo mo-open sa katong part sa book. Okay? Sige. No more questions? Is everything so far understandable na ba?
Self-bias
wala na.
ba itong kuan, sir? Itong previous nga, itong short nga solution.
Kwanto, fixed bias to siya.
Ay, okay.
Kani, fixed bias.
Okay, sir.
Sige.
Sir, nakoy question, sir.
Sige, saman.
Sa atong pagpangita sa X, sir.
Hmm.
Ano na, 11/3 siya, sir. Dari kay 8/3.
Kuan man, ako ang gi-transpose ning X nga naa sa right-hand side padlong sa left-hand side. Di ba na siya 1 nga coefficient? Kani
Yes, sir.
na siya 1. So, it's negative 8/3 minus 1. Check na ko, be. 8/3. Negative 8/3 minus 1 is 11/3. Sakto. Okay?
Okay, sir. Thank you, sir.
Sige. Alright, any more questions? If none, pwede na tayo ma-dismiss. Sige, mag-post lang siguro ko og practice problem for you sa e-learn, guys, para makapractice mo ani Jfet DC analysis. Okay?
Okay, sir.
Okay, sir.
Alright, see you next week. Bye-bye.
Thank you, sir. Bye.
Bye, sir.
Thank you, sir.
Sir,
Bye, sir.
Bye, sir.
Right. Bye-bye.